Then comes nozzle analysis option. So when you want to design any nozzle, so nozzle or the clip design pressure options. At what pressure you want to design the nozzle? So here there are four options. MAWP plus static head, design pressure plus static head, overall MAWP plus static head of governing element, and MAWP plus static head to the nozzle. Usually we are choosing this fourth option. What these four options are there, as we are going to model the entire vessel, then we are going to come to know. Okay. Then nozzle sort options. So you want to sort the nozzles by the naming ascending, descending, diameter ascending, by diameter descending, or no sorting. So usually it is diameter ascending because it will give you 2-inch nozzle in same lines, 3-inch line in different line, 4-inch line on different line. So it will be easy for you to choose from. Then nozzle loads applied at the end of the nozzle. Usually the nozzle loads what has been given to you is at the junction, right? Do you know what is nozzle load? Let's say if there is a nozzle like this, correct? And there will be forces and moments which has been given like this. These are force and then there will be moments. So usually these all are been given at the junction. Okay, this is called as a junction, nozzle to shell junction. So by default, the software will consider the load at the junction. But if you want the loads to be considered at the end of the nozzle, means over here and not over here. So this checkbox needs to be clicked upon. Is it clear? By default, the software will consider the load at the junction. So sometimes the nozzle loads will be shown at this junction. So that is called as a junction load. And if the loads are given at the flange point, at this point, these, if the loads are given at the junction, that is called as a loads at junction. And if it is given at the flange point, it is called as a at the end of the nozzle. So if you want to apply the nozzle loads, in nozzle options, if you want to use the nozzle loads at the end, so you have to click upon this, right? By default, it is to be applied at the junction. So if you want is to enter in the nozzle loads at the end of the nozzle, then click upon this checkbox. This is ASME specific options. No corrosion on inside welds. Many a times, if let's say you are having nozzle which is having protrusion inside, and inside also there is a weld. So many a times if there is a corrosion, so corrosion is also going to happen on that particular nozzles as well, isn't it? Let's say if let's say this is a nozzle which is going even inside, correct? And if let's say there is inside weld like this, and there is a outside weld like this. Are you getting? So now, whatever the process fluid is there, that process fluid is inside, correct? So this process fluid will never come in contact with the outside weld. So the outside weld will be not having any corrosion allowance, and it will not be reducing thickness because of the corrosion. Correct? But the inside welds, it will directly come in contact with the process fluid. So it will be getting corroded. So its throat dimension will be corroded throat dimension. Software by default consider it as the software doesn't understand the MOC and all. That is to be understood by the person who is going to work on the software. Right? So for software, all the material are same. So here, no corrosion on inside weld. Check to disregard the effect of the corrosion on the fillet weld inside the vessel. If you don't want the inside of the vessel, you want to reduce the thickness, then click upon this. Otherwise, it will by default consider. Compute the increased nozzle thickness. If you want the nozzle thickness to be calculated by the software, don't choose this option. Compute and print areas for the small nozzles. So for this, you must be knowing the small opening criteria. Can anybody tell me that what is the meaning of small nozzles? So as per the UG 36C3 clause, UG 36C3. So the code has given you what is the meaning of small opening. If you go to UG 36C3, this must be known to you. That is a prerequisite. Otherwise, you will not be able to understand, right? What has been written. So for opening in pressure vessel, UG 36A like this is B, UG 36C3. This is C, UG 36C. The strength and design of the finish opening. In that, the subclause 3 is this one, UG 36C3. So openings in vessel not subjected to the rapid fluctuations in the pressure do not require reinforcement other than that is inherent in the construction under the following condition. Means what? If the following opening size is there, for that no reinforcement calculations are to be performed. So they have given the sizes. If your required thickness of the vessel is 10 mm or less, so this is called as the required thickness. So if it is lesser than 10, if it is lesser than 10, so up to 89 mm diameter of opening, it is considered as a small opening. And if the required thickness is more than 10 mm, then up to 60 mm, it is considered as a small opening. Are you getting? So let me just model one nozzle over here. Let's say the nozzle size is 80 NB. Can you see over here? What has been written? No area calculation. This is a small opening, right? If I get into this, you will see that what is the opening diameter? What is the opening diameter? 77.927, which is less than 8. So that's the reason why it is called as a small opening. This is less than 89 because your required thickness is less than 10. What is the required thickness? 6.11. Correct? If let's say I am going to increase the pressure such that my required thickness is more. Now what is the required thickness? So now if you get into that nozzle, can you see it has performed the calculations. Now there is no warning or there is no message that it is a small opening. Why so? Because as per the code clause, if the required thickness is more than 10 mm, then up to 60 mm diameter only it is a small opening. Above that it is a normal opening. Are you getting? Right now what is our required thickness? 13 mm, which is more than 10. So what is the criteria for small opening? 60 millimeters, isn't it? And what is right now the diameter is 77. If I click upon this, what is the diameter now? Which is less. So that's the reason why it is called as a small opening. And the software will not perform reinforcement calculation for that. Can you see that? The clause what is there, how, but sometimes this is the code requirement, isn't it? Right now, whatever we are discussing. But sometimes the project specification wants that nozzles always to be checked for the reinforcement calculation. Irrespective of the code, whether it is to be performed or not, I want always it to be performed. So if I'm having that sort of requirement, I have to click upon this checkbox. And if I click upon this, so even for 2 inch, it will perform the calculation. Can you see? It will always perform. Here 52 mm is the opening diameter. Up to 60 mm, it was a small opening. But I still want the software to perform the calculation. So if you want to force that thing, then you have to click upon this checkbox. Is it clear? Is it the code requirement? No. But many times it is the compute and print. If you are using EIL spec or some other specs or IOCL specs, then always they want even the small openings to be checked for the reinforcement. Is it clear? Is it the code requirement? No. Code allow you that till 60 mm, even if you don't perform calculation, it is acceptable because it's a very small opening, right? But if your specification wants it, then you can choose this option. Compute the chord length in the hillside direction. Select this option. You select to use the chord length instead of the arc length when needed for the hillside nozzle calculation. So don't click upon this checkbox. What is the meaning of that? What they are talking about? They are talking about the hillside nozzle. Hillside nozzle means what? The nozzle which is off-centered. If let's say I can extend the center line of this nozzle, does it passing through the center of the equipment? No. So this is called as offset nozzle. This is called as hillside nozzle, also known as offside nozzle. If I am having a nozzle like, so if I am trying to extend its center line, it will pass through the center, right? So this is called as a radial nozzle. What? And here both the center lines are parallel to one another. This is called as hillside nozzle. So that clause was asking that by default the software will calculate this arc length where that opening has been done, and that arc length will be used in the calculation. But if you don't want to use that arc length, instead of that, if you want to use the chord length, this is called as arc, right? This portion is called as arc, isn't it? And this is called as a chord. If I am having any circle or semicircle, so this is called as arc. And when I join this, this is called as a chord length, right? So if you want only the chord to be considered, then you have to click upon this checkbox. Don't check it ever. Consider MAPNC. MAPNC means what? Maximum allowable pressure in new and cold condition. What is MAPNC? NC for NC means new and cold condition. Okay, MAP is maximum allowable. Means what? Let's say you have fabricated one vessel by using 10 mm as a plate thickness. How much? 10 mm. So for this purpose only, it is much important to your code concepts are very clear. If your vessels and the code ASME code concepts are not clear, then you will not be able to understand why it is been written like this, right? So consider MAPNC means what? The equation what we have seen in the code UG27. This was the equation, correct? In the calculation of MAWP we have seen we can back calculate this pressure and subtract the static head. That is called as MAWP. When we are going to calculate any thickness, so how we are going to calculate? Let's say I am going to calculate the thickness. I am having 10 bar pressure. Let's say the radius of the vessel is 500. Allowable stress for let's say carbon steel 51670 material is 138 MPa. Joint efficiency let's assume 1 minus 0.6 into 10 bar. So this will give me one thickness. What it is going to do? Give me one thickness. So let's say by that equation, I have calculated the thickness as 2.5 millimeters. How much? 2.5. Now let's say the process fluid what we are going to use is corrosive. And for 20 years of life, it will be having a corrosion of 1.5 mm. So I need to add that corrosion allowance in that thickness. Correct? This is by equation what we have calculated. That is called as the required thickness. In that we are going to add on the corrosion thickness. So this becomes how much? 4 millimeters. This is called as design thickness. What it is called as? Design. This is required thickness. This is design thickness. Does this is the final thickness? Then we are going to compare this thickness with the market available thickness. Let's say 4 mm is directly available in market, we will go for 4 mm, right? But if let's say 4 mm is not available in market, then we may have to go for 5 mm. Are you getting? Let's make it little bit different. So let's say this is 2.6, this is 1.5. So the addition would be how much? 4.1, right? 4.1 mm thickness is not available in the market. So what we are going to go? 5 mm thickness. So this is your required thickness, this is your design thickness, this is your nominal thickness, which you are going to procure from the market. So when I am going to have the shell in the shop fabricated, what will be the thickness of that shell? 5 mm. So the thickness which is in new and cold condition means whenever you are going to manufacture it at that particular time, what is the thickness available? That is called as new and cold condition. It is not been used yet and that's the reason why it is new, and it is not in hot condition, it is in cold condition. Are you getting me? So if I use 5 mm as the thickness and back calculate the pressure, let's say it is 18 bar. How much? 18 bar, roughly, approximately we are talking about. These are not the actual values, just for understanding purpose. So, does this 18 bar is our MAWP? No. When we are going to calculate MAWP, we should not take credit of any corrosion allowance. Okay. So, if I want to calculate MAWP, this particular thing what we have calculated is called as MAPNC. Okay. Maximum allowable pressure in new and cold condition. So maximum allowable working pressure definition, if we read in the code, it is mentioned at, it is the pressure maximum allowable capacity at the topmost position in the corroded condition. So if you go to the definitions, here you can see MAWP. Can you see maximum allowable working pressure definition? Right? It is given in mandatory appendix 3. The maximum gauge pressure permissible at the top of the completed vessel in its normal operating position at the design coincident temperature for this pressure. This pressure is the least of the values for the internal or external pressures to be determined by the rules of this division for any of the pressure boundary parts, including the static head thereon, using which thickness? Nominal thickness. What it is been written after that? exclusive of the allowance for the corrosion and considering the effect of any other combination loading. So let's say here, what is our nominal thickness? 5 millimeter. How much is the corrosion allowance? 1.5. So what is available thickness now? 3.5. So we are going to use this thickness to calculate the pressure. Let's say that comes to be 15 bar. How much? Now this pressure from where we have to subtract the static head. Let's say static head is 0.5 bar. So it will be 14.5 bar as the MAWP. Because MAWP is measured at the top of the vessel. Let's say this vessel is filled with liquid. Okay. So the MAWP is measured over here. So consider MAPNC. If you want the nozzle and this MAPNC to be considered in the calculation, then we have to click upon this checkbox, right? Then consider external loads for the nozzle TR. TR is the required thickness of the nozzle. So in the calculation of the nozzle thickness, the external loading should also be considered. So always click upon this checkbox. So the nozzle neck thickness will be checked not only for pressure but also for the external loads if those are applicable. For division 1, use appendix 1-9 for internal pressure instead of UG 37. Never use this. Use appendix 1-10 instead of UG 37. 1-10 is the old appendix which is now absolute. 1-10 is not applicable now. But some of the vessels you might be doing which was done, let's say 10 years back, now you are going to replace some of the part, and if you want to keep the design code same as that of old, so these are the check boxes that you can click upon so that the software still can be able to perform the calculations with those guidelines. Okay. ASME, don't click upon any of the check boxes. That is in nutshell what we can say, unless and until you want specifically something to do. Use large nozzle calculations. Can you see over here 1-7, 1-10? Always keep 1-7. 1-10 is obsolete. That has been removed from the code. But the software does have these all options still available so that if you want to use it, can you see over here? Till what we are having this 1-8, right? 1-9 and 10 has been removed from the code. It was in the earlier version of the codes. Is it there now? No. 1-9 is not there, 1-10 is not there, correct? But these options are still here. Why so? Because if you want to use the software for the older versions of the codes, you can still be able to use by clicking on this checkbox. So in normal calculation in today, we are not using this, isn't it? So ANSI flange pressure reduction option. So do you know about flange derating? So if your nozzles are having any external loads, so as per the code UG44B clause requirement, we need to perform the flange derating calculations on welding neck flanges. So for that purpose, this option to be chosen. By default, it will be ASME UG44. Don't change this. Okay. Use user defined FM values for the ANSI flanges. So by default, if you go to UG44B, so they have given FM values. Now, if you are not aware of that, then it will be difficult, right? Because you first understand the code requirement, then you can use the clauses over there very nicely. Can you see here UG44 comes UG44B for external loads. Here they have given one table UG44-1. So here there are values of FM. Can you see? These are called as the values of FM. These values will be used in this equation. Okay. If you don't want these values to be used, instead of that, if you are having your own values of FM, let's say if you want to use code case 2901-1, so it will be having different values of FM. That is not a part of code. So you can click upon this checkbox. You can go to that system folder, change the values over there, and the software will use that. So don't click upon this for any regular calculation. Consider nozzle loads for UG45. Include the applied nozzle loads in determination of the minimum nozzle neck thickness as per UG45. So click upon this checkbox. Consider the nozzle loads for UG45. UG45, if you go, it will ask for UG45 is the clause to be used for the nozzle neck thickness calculation. This is for nozzle neck thickness calculation, right? In this TA, if you just read the effect of the external forces and moments from the supplemental loads as per UG22 loading shall be considered, right? You want to take care of. So in software, you have to click upon this checkbox. Okay. Then comes nozzle openings. MAWP is not restricted by the shell. If you are having this specific requirement, this is not code requirement. So you can click upon this. No B31.3 stress checks on the nozzle. So the nozzle necks will be checked for the external nozzle loading as per B31.3. So if you are having WRC 107, so usually these are by default considered. So don't click on any of the options which we haven't clicked over here. Can you see this? So you just make sure that your settings should be similar to what I am showing over here. That is what in nutshell we can draw it from here. Is it clear?